This is the 85-year-old Glenelg Golf Course, located on a dune complex on Adelaide's coastline. The club, Daryle Sellar, course superintendent, and his greens management team are well on the way to ensuring the club's current and future water needs as a result of the implementation of an ambitious project that started over 10 years ago.
We host something in the order of 65,000 rounds a year, so it's pretty busy for a private course. With the changes we've made, the course's sort of standing in the national rankings has improved dramatically from at one point being in the 90s to now being ranked as high as 29. It's really nice to hear the members say that they're proud of their course and proud of what we're doing. Water's the biggest input that we have to our golf course. In a climate like Adelaide's, the quality of that water has a huge bearing on our ability to produce the quality playing surfaces that we're really looking for. So a key driver of this whole scheme was to secure not only the volumes of water we needed, but a better quality water source for the golf club so that it could meet the quality objectives it had for the course looking into the future. The water we harvest is actually harvested from Brown Hill Creek. It's pumped along the channel via some pipes and then moves into the first stage of the wetland scheme. The water takes about 3 days to move through the wetland scheme, moves under the 17th fairway, wraps around the 16th hole and ends up here at the bottom end of cell 3. After that 3 days of movement and treatment, the water is monitored. There's a live monitoring station just over here at the harvest point, and assuming the water gets through the quality criteria, it's then pumped several hundred metres back to 3 of our 4 bores on the course and injected underground for storage. If there is an increase, a spike in turbidity or pH or something like that, the system will automatically shut down and won't enable us to inject that water underground. In this wetland scheme, we've got about 14 megalitres of water. It gives you an idea of the magnitude and the scale of wetland required to treat the volumes of water we need to meet our irrigation needs through the course of a year.
The scheme was joint funded by the state and federal governments and helps to manage localised flooding and reduce the outfall of pollutants released into the marine environment.
So we've had the system operational and in our hands for the last 2 years. There's been some teething problems. We've not probably operated it as efficiently as we could have, but nonetheless, each year we've been able to inject 100 megalitres over each year for the last 2 years during the winter period. And so that's represented about 50 to 60% of our irrigation needs of that period. But the system itself has the capacity to produce 300 to 400 megalitres of water for us if we need. Our annual requirement's closer to 200. So yeah, once we're up and running, we should be 100% stormwater. Where we're standing right now is one of the low-lying areas of the golf course, and if we were to dig down about 1 metre at this time of year, we'd reach our water table, which is contains saline groundwater, and clearly at 3,000 to 5,000 parts per million, we don't want that water intruding into our fresh stormwater that we're using for irrigation and injection. It's in this area here, where this cell 1 is, that we were thankfully able to mine a suitable clay and in sufficient quantities to line all of these wetlands to a depth of 400 millimetres to ensure that there was no intrusion of saline groundwater. So we can virtually monitor the status of the system at every point, from harvest over at Brown Hill Creek to the status of the wetlands themselves, including their water level and the water quality as it stands at the moment. You can see that's registering as a fail because the salinity level is a bit too high, and that's reflective of the fact we haven't had rainfall. We haven't been able to bring in any fresh water for a number of weeks, number of months, and so salinity is a bit high at the moment. We need a good flush of rainfall to bring in some fresh water to get that level down. But that gives us a status on the pumps as well, so we can pick up any faults fairly quickly. Gives us readings on pressure and flow, salinity levels obviously, right through to each of the bores, and we get an indication of their static levels as well. So it's a very comprehensive scheme right through to our irrigation tanks, so that we can monitor the water level in there and give us an overview of our pump system at the irrigation system as well. So it's something that we can come in, view first thing in the morning, make sure that everything's performed accurately. We can bring up trend lines on pump statuses and bore levels, so it helps us to troubleshoot if there has been a problem. So it's been very, very beneficial already, and produces a lot of data that will help us from our record keeping point of view. Monitoring can be very time consuming, and it's a key component to these schemes, both from a compliance point of view but also just from a basic operational point of view. You need to be aware of how the system's performing continuously. We were very conscious at the outset. We had a system that enabled us to monitor all of that from one central point to improve efficiency and to give us as much information as at our fingertips as we could have, and it's proved invaluable already. In 2 years of operation, it's helped us to troubleshoot, helped us to identify problems before they became operational problems, and gives us the data that's required for our EPA compliance parameters as well. So very, very essential, and it's something that I'd highly recommend you take. Anyone looking at a similar scheme pays really close attention to, is getting this sort of information at their fingertips. This is one of our injection and production bores, so we inject water underground here but then harvest it when we need it during the summertime. So this one's in what we call our T1 aquifer. We've got 2 aquifers under the golf course. The T1 in round terms is about 100 metres deep. The T2 is about 200 metres deep. We've got 2 of the bores injecting into the T1 aquifer and one of them injecting into the T2. The aquifer is a very slow moving aquifer, very stable, which is conducive to this sort of scheme, injecting water and keeping it underground. The water only moves about half a metre a year, but we've aligned the bores so that over time, if a bubble or plume of fresh water does accumulate underground, they will eventually merge after 50 or 60 years. We monitor soil moisture, salinity and soil temperature, not so much to dictate our irrigation, but to enable us to monitor the impacts of our irrigation practices. Whilst we don't sort of set our irrigation based around what these sensors tell us, we use it to confirm that some of our practices are working or refine them if perhaps they're not. I can't be more complimentary of the staff here, for the way they've taken it on board and really own the scheme and the system and what we do. One of the key things about this whole scheme has been to get committee support initially and member support in the longer term, because we spent quite a bit of time, if you consider the timescale that this scheme's taken to get to where it is now, it's about 12 years. And quite a bit, the first couple of years were about educating the committee on the need to go down this path, why we needed to consider a better quality water source, and whatever that may have been. And to the committee's credit at the time, they embraced it and were very supportive of it. They listened and were prepared to be educated on it. And that's flowed through to our membership. We've done, I think, a pretty good job of communicating to our members why we need to put this scheme in place, what the benefits will be. And certainly the drought was in some ways came at a very timely, it was a very timely event, because it really highlighted the magnitude of water supply problems. But I'm really proud of our members for the way they've embraced the concept. They seem very proud of the scheme, very proud of what their club's doing and has done. And it's made the whole process a lot easier for us, because they've got an appreciation that it's not just about water for water's sake. It's water water supply, and securing a water supply that's consistent with our whole integrated pest management philosophy for the golf course, where we're trying to create a healthier growing environment for our turf so that it produces more consistent quality playing surfaces for them throughout the year, but it's also easier for us to manage, less reliance on pesticides and other chemicals and fertilisers. And they've embraced that philosophy really well, and I think, as I say, I'm really proud of our club for the way they've adopted it.